This is Chapter 8, 8.1, Graphing f of x is ax squared. And this is a quadratic function, which is a nonlinear function, so it's not a straight line, that can be written in the standard form y equals ax squared plus bx plus c, where a is not 0. So this x squared term has to be here. And a quadratic function graphs as a parabola, and a parabola is a U-shaped graph. We have a few characteristics of quadratic functions. We have the parent function, which is f of x equals x squared. And all the graphs of other quadratic functions are transformations of this. We have the vertex, which is the lowest point on a parabola that opens up, or the highest point on a parabola that opens down. So it's what would be like the corner of it, but since it's a U, it's not an actual corner. The vertex on the parent function is 0, 0. And we have the axis of symmetry, which is the vertical line that divides the parabola in two symmetric parts. It goes through the vertex, and for f of x is x squared, the axis of symmetry is the y-axis, so it's x equals 0. If we look at a graph of a parabola here, it opens up. This would be like the parent function, where the vertex is 0, 0, and the axis of symmetry is that y-axis. And on the left side, the slope would be negative. The y's get smaller as we read from left to right. So we would say this is decreasing. And on the right side, the y's increase as we read from left to right. The slope would be positive here, so we say this is increasing. If we graph f of x equals ax squared, we have a few things. If a is positive, so a is greater than 0, and it is less than 1, this is a vertical shrink. The parent function is this blue one, and the vertical shrink would be this orange one. So for these same x values, it just gets shorter. It looks like it's wider as well, but it gets shorter. If a is greater than 1, this will be a vertical stretch. So to go from the blue to the orange, those x values get taller. If a is negative, so a is less than 0, we get a vertical shrink if it is between -1 and 0. And it would shrink, so it gets shorter and wider, and it also reflects in the x-axis. So that's what the negative does. It makes it flip over. And then if a is less than -1, it will be a stretch where the y values get further away from the x-axis in comparison to the parent function. So stretches get taller and skinnier, shrinks get shorter and wider. If the number is less than 1, it is a shrink. If the number is greater than 1, it is a stretch. Negative makes it go upside down. So we're going to graph a couple parabolas here. And to graph them, we have a few steps. We're going to make a table of values, where I get to pick the x's and you get the y's that go for those. You plot the ordered pairs, so you put your dots down for x, y, and then you connect the points with a smooth line. Because it's a U, we are going to have a smooth line. So we're going to graph f of x equals x squared, and f of x is 3x squared. So I'm going to make a table for x squared. This is the parent function, and we're just going to do this one for this one problem, and then the parent function is always the same. So I'm going to be able to use these points in other graphs. So picking x's that are close to 0 on the positive and negative sides, plug them into my function, and get my corresponding y values. Then I have my ordered pairs, and I get to plot those on my graph. Then I'm going to pick my x values and plug them into my second function. So plugging them in, do your squared first, follow your order of operations, do the squared first, then multiply by 3, and you get your new ordered pairs. Then when I plot those, this is my parent function, and then the orange one here is the second function. So if I compare them, they both open up, and they have the same vertex, and the second graph is narrower, it's skinnier, because it got stretched. Now here's a second set that we are going to graph. F of x is x squared, and g of x is negative 1/2 x squared. So parent function is the same. I'm just going to pull my ordered pairs from the first table that I did in my last example. Then I'm going to make my table for g of x. So pick your x values and plug them in, and then do your squared first, then multiply by 1/2 and make it negative. So then you get your ordered pairs here, and you can plot them. Parent function stays the same, and since it was a negative, this one opens down. And it looks shorter and wider. If I continued this graph on, I'd be able to see a little bit better of how much shorter and wider it is. But if I look at, take a point, and this is 4 away from the x-axis, the same x value on my new function is only 2. So to go from 4 to 2, it shrunk to half its size. It shrunk by a factor of 1/2. So these have the same vertex here at 0, 0. G of x opens down, and g of x is a shrink by a factor of 1/2.